I'm going to start by looking at a unit circle. Feel free, as usual, to either ask your questions out loud or put them in the chat because I am monitoring the chat at the same time, right? But I am recording, but not your voices. Your voices will not be heard as we go through, right? Okay, so let's start off with the unit circle. What do I mean by a unit circle? It's a circle that has a line going from the center out to the edge of the circle, which is 1 unit long. So if this line, this vector, we can call it a vector because a lot of you are going to be doing the vector course later on. If this vector or this line, this radius was sitting right on the x-axis, then it would be touching the point 1, 0. Right, it'll be touching this point right here because it's 1 unit long. So this distance here, right, this distance here, which is the radius of the circle, it would mean that it would be sitting right on the x-axis, and that would be at 1, 0. And if we were to rotate that, right, in a counterclockwise direction, so let's say we're going in this direction here, counterclockwise this way, then we would get to a point where it's sitting on the y-axis, and then those coordinates would actually be 0, 1. If we were to continue that and continue that counterclockwise rotation, at some point you're going to get over here sitting on the negative side of the x-axis, in which case it would be -1, 0. And also, if you continue that and down to this point down here, then the coordinates of this point, of course, would be 0, -1. All right? So what are these angles of rotation I'm talking about? Well, if you measure, I will call it standard position. If you measure this angle as the angle between where the line is and the positive side of the x-axis, then you're starting off at 0 when you're at 1, 0. If you continue that up to this point, this would be in the old system, we call this 90 degrees. But in the new system, we're going to be calling this now pi over 2. So think of what used to be 90 degrees as pi over 2. Over here, so now we'd be at 180 degrees, but think of 180 as being pi, right? Pi is the same equivalent angle in radians as 180 degrees. If we were to come down here, this angle down here, so remember, we started off at 0, we went through pi over 2, we went through pi. So what is this angle down here? What do you think this angle down here is? I'm asking you, don't have to answer, it's up to you. What do you think this angle down here is? That used to be called 270 degrees, right? So what do you think that angle would be down here, right? Remember, this is 0. Let me put 0 on the side here. This is pi over 2. This is pi. What do you think this angle down here would be? No, we're not at 2 pi quite yet. 2 pi, just so you know, would be a full 360, which is the same thing as 0. So this would be 2 pi over here, or 2 pi. But this is not quite 2 pi yet. Think about that, Davina. Think about what this, I'm not just Davina, everybody else. Remember, this is 0. This is pi over 2, right? Which is kind of half a pi, right? Or what we used to call 90 degrees. This would be pi, or 180 degrees. Down here would be 2 pi, but this is not quite 2 pi yet. How many pi's do you think this would be? Can anybody give me an answer for that? So it could be minus pi over 2 if we're going in a negative direction. You're right about that. But if we continue going in a positive direction, Christiania was thinking minus pi over 2, which is not wrong if I'm going in a negative direction. But what if I'm going in a positive direction? Positive direction means I'm going in a counterclockwise direction. So I'm going in this direction. So remember, pi over 2 is here. Pi is here. And if I were to slip past here and go all the way, that would be 2 pi. So what about this one right here? Thank you, Mohammed. That's great. It would be 3 pi over 2. So this would be 3 pi over 2. Okay? So far, so good? Right? And then if we were to continue, we'd get right back to the start again, which would be 0, or we could call that 2 pi as well. Because remember, 2 pi is the same thing as 360 degrees. So they're equivalent. Now, I want you to think of, and by the way, does 3 pi over 2 make sense to everybody? I just want to make sure that everybody is okay with that answer. 3 pi over 2 makes sense. If you're not, I can certainly go over it some more. Okay, some people are saying yes. No, maybe you never learned this before, but I'm going to say this right now. I want you to think of your sine, me go back to my, in fact, let me go to black now. I want you to think of sine as being your y coordinate. I want you to think of cosine as being your x coordinate. I'll explain what all of that means in a second. And I want you to think of tangent as being your y divided by your x coordinate. We can use that. Do you mind explaining it? I don't mind at all, Donna. I don't mind at all. One thing you could do, Donna's asking me to explain, but again, I'm fine with that. One thing you could do is use the two things that we learned from the previous lesson to make that conversion. So if I multiply 270, put it aside here, by pi over 180, right? Remember that was a conversion factor, Donna, from before? You remember that conversion factor that we used? The pi over 180? Okay, so let's cancel this down. Think of 270 pi over 180. I can divide both of these by 60, right? 60 goes into 180, or is it, no, let me go by, no, sorry, let me go by 90. Sorry, not 60, 90. 90 goes into 180 twice. 90 goes into 273 times. I get 3 pi over 2, which is exactly what we have right here. Okay? All right. So use that if that helps you to make that transition. Multiply by the factor which converts from radians. See, I want you to start sort of translating from degrees into radians. I know if I said 90, 180, and 270 and 360, everybody would be okay with that. But now we're trying to see if we can think radians rather than degrees. Okay? All right. So there we go. So what I'm also saying, I'm going to erase this thing right here for now. What I'm also saying is that think of sine as being my y coordinate, think of cosine as being my x, and think of tan as being my y divided by my x. That means that we can now answer the question of what the sine of 0 degrees is, because the sine is my y coordinate, what the cosine of 0 degrees is, and what the tangent of 0 degrees is. If we think of it in terms of coordinates, because that's really what it is, right? Sine, cosine, and tangent are really just coordinates on a circle as you revolve through, starting off at 0 and going in a counterclockwise direction. So let's start off at 0. 0 was over here when you were at 1, 0. So the sine, in fact, we can go to the next table. The sine of 0, if we just go back, and I'm going to go back and forth on this. The sine of 0 is my y coordinate when I'm at 0 degrees. At 0 degrees, my y coordinate is 0. I'm pointing it out. I'm circling it right now. So it means that my sine of 0 is 0. Let's go to cosine. Cosine is my x coordinate. So at 0, which is where I am right now, my x coordinate is 1. So it means that my cosine is 1. How about my tangent? The tangent says take my y divided by my x. So that's going to be 0 divided by 1. And that, of course, is 0, right? If I divide 0 by anything, I still get 0. Now, dividing by 0 is a different thing. But I can have 0 as a numerator. And if I have a 0 numerator, it means that my answer is just going to simply be 0. So the tangent is 0. We'll get to cosecant and secant and cotangent a little bit later on. Let me now go to pi over 2. So this line right here, let's try to fill that in. So for pi over 2, I'm going up this green spot right here. This is where I am right now, my pi over 2. What is my sine at that point? Sine is my y, so that means that will be 1. So the sine of pi over 2 should therefore be 1. How about the cosine of pi over 2? The cosine, remember, I'm up here now, pi over 2. The cosine of pi over 2 is my x-coordinate. Well, my x-coordinate is 0. So that means that my cosine of pi over 2 should be 0. That's my cosine. Let's get to the tangent. Right? I'm at pi over 2. I'm up here. What should be the tangent of pi over 2? Well, tangent according to this thing is take my y divided by my x. So here's my y, which is 1, divided by my x, which is 0. So what do you think the tangent of pi over 2 should be then? I'm trying to divide by 0. It's undefined. So there you go. I'm going to put that as being undefined. And I'll just put the infinity symbol for that. That's one way to write undefined. You can write UNDF if you like, undefined. Either way, it's the same. Oh, I think I put it in the wrong column, actually. Wrong column. So UND, and I'm going to erase this. Okay. How about if I were to try this for, we're going to get to some of these other ones in a little while. What if I were to try this for pi? We'll do that last one, right? So pi. Let me go back and show my chart again. So remember, pi is over here, right? That's what I'm circling right now. That's my pi. Sine is my y. Cosine is my x. Tangent is my y over my x. Without me giving you the answer, who can tell me what the sine of pi should be based on what we just said? Sine, remember, is your what? Absolutely, Alexa. Well done. It should be 0. So let me go back down for pi and put in 0 for sine. How about my cosine for pi? Okay, you anticipated that question. You know where I was going with that. The cosine should be -1, absolutely, because that is my x coordinate. So -1. And how about my tangent? What do you think my tangent is going to be? Remember, the tangent at that point is my y divided by my x. Hussein and Alexa say 0, and I absolutely agree with them. 0 makes perfect sense. Put 0 over -1. So again, for pi, I'm going to put 0. Now, there are some other ones that we're going to get to later on down here. I'm not going to do 3 pi over 2. I'm going to leave that to you to figure out on your own. At 3 pi over 2, again, just get your x coordinate and your y coordinate. You see, what I'm trying to get you to do is to see what happens, and you get these questions on your homework. What happens when I'm sitting on an x or a y axis? What happens when I'm at 0? What happens when I'm at pi over 2? What happens when I'm at pi? What happens when I'm at 3 pi over 2? What happens when I'm at 2 pi? 2 pi and 0 are in the same position. So whatever answer I get for 0, it'll be the same thing for 2 pi. Let's just make sure we understand that. So right now, we have a way that we can answer any of those questions on the homework once I'm sitting on an x and a y axis. You should have no problem getting those answers. Just think about what your x coordinate is, what your y coordinate is. If it's sine, then it's your y. If it's cosine, it's your x. If it's your tan, then it's your y over your x. Now, there are some reciprocals that we should also consider. So cosecant is the reciprocal of sine, secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. Those are some things. Does anybody remember that from grade 11? Please tell me yes. Please tell me that you did that stuff in grade 11. What are called the reciprocal trig ratios. Cosecant, secant, and cotangent. Excellent. So Kelvin and Alexa and Donna remember that from, and Hussein remember that from their grade 11. So let me go back and show you what that actually means then. So in this case, when it asks for the y coordinate, right? We're going to take that y coordinate and we're just going to, in this case, that's 0, and we're going to, again, just flip it over, make the reciprocal of it. The reciprocal of 0, of course, so we're talking, let's talk about cosecant first. If I took this answer and flipped it over, what answer should I get for cosecant of 0 degrees? All right, so take the answer that we have for sine and flip it over. What do you think that should give us for the cosecant of 0 degrees? Can anybody think of what that answer might be? So you have 0 right now. Let's put it this way then. What you really have right now is 0. You can put it over 1 if you like. That makes it easier for you to see. So it's undefined. We just take 1 over 0, which therefore means that this, the cosecant of 0, is undefined. I use the infinity symbol. You could put UND if that makes sense. How about the secant of 0 degrees? The secant of 0 degrees. So take that answer and flip that over. What do you think that would give you if you were to flip that over? All right, the cosine of 0 is 1. What should be the secant in that case? Remember, it's a reciprocal. So whatever answer you get, put that over 1. Right? So right now we have an answer of 1. Flip that over. All right? So Kelvin says it's still 1. What do other people think? He said, well, okay, I think his answer to this one, well, I'm not sure which answer he's giving. I say undefined and I see 1. Which one is it, folks? Let me ask the whole class that. For cosine, all right, Hussein, it is 1. It is 1. It is absolutely 1. Right? You take 1 and flip it over, it's still 1. How about cotangent? The cotangent of 0. So again, for 0, now here's what I want to caution you about. For tangent, it was y over x. And I'll just put this on the side here. For cotangent, it's actually x over y. Think about it that way. Flip this over. Take the answer that you got before, which was itself a fraction, and flip that over for cotangent. So it's the x coordinate over the y coordinate if it's cotangent. Right? So think about what it is at 0. Okay, think about what it is at 0 degrees. Instead of putting the 0 over the 1, we're putting the 1 over the 0 because it's x over y. So that would mean that for 0 degrees, the cotangent should be, what do you think? Should be undefined, absolutely. I'll just put UND again to mean undefined. Okay? All right. Let's see if we can do the same thing down here for these other ones. Let's fill these ones in. How about remember this is the cosecant of 1. What should be the cosecant of 1? So, not 1, sorry, pi over 2. Pi over 2, I meant to say pi over 2. The cosecant of pi over 2 should in fact be 1, absolutely. All right. How about the next one? Remember, this one was 0. So what should I put as the secant for pi over 2? That's what the cosine was, 0. So what should be the secant of? It should be undefined. There you go. Now, okay, I see a hand going up. Let's get to that. Quinn, yes, Quinn, go ahead, please. I sure can. I sure can. So let me go back to that. So he was asking for the cosecant of pi over 2. So this was remember, cosecant, by the way, is a reciprocal of sine. Right? So you take the sine answer that you get and flip it over. So the sine answer for pi over 2, we said was 1. We'll take 1 and flip that over. So that's like 1 over 1 if you want to call it that. So take 1 over 1 and flip that. It's still 1 over 1. So you still have 1 as your answer. Does that make sense? So I want to make sure that's okay with Quinn. Okay, good. And thanks for the question, by the way. All right. So now this last one is going to be a little bit tricky. Let's just be careful now. All right. This last one is the tangent of pi over 2. No, remember, the tangent was undefined at pi over 2. But what about if I were to take that and flip that over? Now remember, let me remind you that the cotangent is actually the x divided by the y. So here's pi over 2 right here. Here's my pi over 2. Put my x, put it over my y. Krisania and Hussein, absolutely 100% correct. It would be 0. Right? So if you flip over the undefined, you're actually going to get 0 this time. We'll do that one more time for this one here. This line here, we'll try that one as well, and then we're going to go to another triangle. Sorry, we're going to go to the triangles after that. If it was pi, what do you think would be the reciprocal of that for cosecant? Remember, this is sine, this is cosecant. What would the reciprocal of that? That's undefined, good. Or I'll put a little symbol there. What minus 1? If I flip over minus 1, what am I supposed to get? It's still minus 1. And how about this 0 here? What happens to that 0? It's undefined. Okay, well done. Good. Okay, so I'll leave the others for now because we need some more work. There's a homework assignment due today. I'm expecting it done by the end of the day, yes. All right, it's just 20 questions. Is it always going to be over 1? In a sense, yes. Be careful with the tangent though, because the tangent, not the tangent, the ones that are undefined, when you flip over undefined, it becomes 0. Let's put it that way. Okay? If that makes sense. But yes, you can always put anything over 1. Okay, Sindhuja? Can you give us an example, another one on the chart? Well, the rest of them on the chart mostly are going to be require some more explanation because they're not on. These are not sitting on the x or y axis. I need to go over the triangles with you for that. So we're not quite ready for the others just yet. How did you find cotangent again? Okay, so for cotangent, remember we said that tangent was the y over the x. Sorry about the chair. I need to get a chair. I need to put some oil on this chair. I know it's squeaking a lot. And remember we said that tangent was y over x. I'm going to put x over y for the cotangent. Okay? So look back at your grid, right? Look at your coordinates at wherever you are and put the x over the y for cotangent. So it's flipped, exactly. So instead of y over x, it's now x over y. Okay? All right. Hopefully that, okay, you're welcome. Okay, now that takes care of what happens when I'm sitting on the x or y axis. So if I'm here, so 0, pi over 2, pi, 3 pi over 2, or 2 pi, or 0, back at 0. Can you scroll down a little? Okay, Brendan, can you see what I was, you asked me to scroll down. Is that enough for you? Okay. All right. So that takes care of when you're sitting on the x or y axis. But not all angles for special angles are on the x or y axis. Let me take you now to some what are called special triangles. You've probably seen these triangles before. Hopefully you have from grade 11. Hopefully it's not the first time you've seen these triangles. Donna says yes. Good. Chrisania says yes. So the first one is an equilateral triangle. Equilateral means all the sides are the same, and each side we're making 2 units long. It doesn't have to be centimeters or meters or yards, or it's just 2 units long. We don't really care what the units are, it's just 2 units long. It's an equilateral triangle, and we took one of the sides and split it in half, and therefore, since all the other sides were 2, that means that this side is going to be 1 and 1. So 1 on one side, 1 on the other. If we use Pythagoras, without me going through Pythagoras' theorem with you, then this side here becomes the square root of 3. And you can try that on your own. You know what the Pythagoras theorem says, so you know that you can actually work this side out. If you know what this side is 1 and that side is 2, this becomes the square root of 3, and that's easy enough to figure out. Now, when you were doing this in grade 11, they told you that these angles were 60 degrees. And then these were each 30 degrees. Because remember, a triangle is 180 degrees, and therefore, since it's equilateral and all the angles are the same, then we split it up into 3 and so on and so forth. But we have left degrees behind grade 11. Now we got to start talking about radians. Uh-oh. So let's take this angle, which used to be 60 degrees in the old school, and bring it into the radian world. What angle would this be in radians? The one I just marked off here. Give me a radian answer for that angle. What do you think that angle is in radians? So again, you can multiply it by the pi over 180, reduce it down to its lowest terms, and that would be the radian angle. Right? So it was 60 degrees. Well, it still is 60 degrees, but we're not using 60 degrees anymore. We're going to put it into radians. So work that out right now and tell me what you think the answer is in radians. The same angle, which used to be 60, is now what in radians? And anybody help me with that, please? What's the answer in radians? Sindhuja says pi over 3, Kelvin says pi over 3, and I completely agree pi over 3 is the answer. So that means that this is also pi over 3. But what about these two angles up here? Well, if I'm only looking at one side of it, let me erase the other side for now. And only looking at this side right here, that's half of pi over 3, right? So what would that angle be in radians? Take pi over 3 and divide it by 2. How do you get pi over 3? Okay, well, let me do it this way then, Davina. there are 2 ways we can look at this. And I'm glad you asked the question, by the way. And I, even though you're not required to be here, I really appreciate that you're taking the time to first of all be here and to participate and have input in it. Let me do this then, Davina. Let's take a typical triangle and ask how many degrees. So we're talking degrees again. How many degrees would you have in a typical triangle? How many degrees in a triangle, Davina? You tell me. What did you learn back in elementary is a number of degrees in a triangle? Do you remember, Davina? A triangle has how many degrees? Not radians, degrees. All triangles have how many degrees? Do you remember? Anybody, it doesn't have to be Davina. How many degrees in a triangle? Nobody remember? How many degrees in a triangle? 180. Thank you. Okay. How many radians is 180? Right? 180 degrees is how many radians? Convert now 180 degrees into radians. Remember what we said? It's pi. Okay, great. So, does pi make sense, by the way, Davina? That 180 degrees is the same thing as pi radians? Good. Take that and split it 3 ways. Right? Remember, a whole triangle has 3 angles, and we're going to split that pi 3 ways. So wouldn't each one be just 1/3 of pi then? Wouldn't that make sense? Does that sound about right to you, Davina? All right, perfect. So that's why we get the pi over 3 there. That's one way to do it. The other way is to use that factor that I was just saying to Donna a few minutes ago. And I'm going to write it on here. I'm going to just sort of remind you about that. What used to be 60 degrees, multiply that by pi over 180. Just reduce that down. You're going to have 60 pi over 180. Reduce the 60 and the 180 down to 1 over 3, or just simply pi over 3. So that's the other way to look at it. Okay? So I just thought I would quickly, and I have no issue with you asking the question, because I want to be able to answer those questions, because other people might have those questions as they're watching this later on. Okay, so we already asked about this other angle up here, which is splitting this pi over 3 in 2. So what's half of pi over 3? And I got the answer earlier on as being pi over 6, and that's absolutely correct. Oh, sorry. That angle is actually pi over 6. Is everybody clear on pi over 6? Or do I need to show you how half of pi over 3 is pi over 6? Everybody clear on that? Okay, Sanduja says yes. Everybody else okay with that? Hussein is yes. And Alex, okay, good. I'll take that as being everybody's okay with that. And I'm always quite happy to go through it in more detail if anybody needs me to. So that's triangle number 1. Let's get to triangle number 2 now. How did you get that? Okay, Donna. Thank you, Donna. So let's do it this way, Donna. Pi over 3 divided by 2, right? Or divided by, let's say, 2 over 1. Is that kind of the same thing? Right? So dividing by 2 over 1 means the same thing as pi over 3 multiplied by 1 over 2. Multiplied by the reciprocal, in other words. How do we get 2? Because we split it in half, exactly. Right? So we're getting 2 because we're taking the pi over 3 and we're taking a half of that. We're splitting that angle exactly into a half. So that gives us pi over 6 in that case. Okay? All right, good. So I'll just erase that now. Okay, let's get to the second triangle. What about these angles in the second triangle? Now remember, all triangles are what we used to call 180. We don't call it that anymore because now we're dealing in radians. This here is what we used to call 90, that's the right angle, what we used to call 90 degrees. But now we're going to call this, we just had this in the previous thing, we're going to call this pi over 2. Because that's what 90 degrees is. The rest of this triangle has to be split between these 2 equal angles. This is an isosceles triangle. It's not an equilateral, it's an isosceles triangle. So this is a half of that full 180 degrees or full pi radians is in this right angle. The rest has to be distributed equally between both of these two angles. So what is the size of those two angles? Okay, you're saying 30 and 60, but they're equal though, Christiania. Those two angles have to be equal. It's an equilateral, no, sorry, it's not equilateral. It's an isosceles triangle, right? So Quinn says 45 and you're right, but can we convert that into radians, right? Yes, so it's 45 degrees, but let's turn that into radians. So go through the process again. Quinn says pi over 4, and I agree. That's pi over 4. That's half of pi over 2, or just multiply the denominator by 2, so pi over 4. And in fact, this one up here is also pi over 4, because they're both equal. Okay, so we're going to, thank you, Quinn, and thank you everybody else who jumped in on that. We're about to take you back to SOHCAHTOA, okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is adjacent over, opposite over adjacent, all that stuff that you learned in grade 10. We're going to use that right now to figure out the sine, cosine, and tangent of these angles. Let me start off with the sine of pi over 3. That's this angle right here, pi over 3. So sine, remember, SOHCAHTOA, is opposite over hypotenuse. Hopefully that makes sense. Hopefully that's something you remember. So the sine of this angle I'm pointing to right now is the opposite side, which is root 3 over 2. That's the sine of pi over 3. The cosine of pi over 3, let's go back and think about cosines. Adjacent over hypotenuse. Adjacent to this is 1. The hypotenuse is 2. So the cosine of pi over 3 is 1 over 2. The tangent is opposite over adjacent. So who can give me what the tangent of this angle is? The tangent of pi over 3 is equal to what side over what side? Opposite over adjacent. Come on, let me turn it over to you now. Right? What would the tangent, just using SOHCAHTOA, so root 3 over 1, perfect. And of course, because it's over 1, it's just simply root 3. There you go. So we just figured out a special angle in what's called exact form. So yeah, root 3 is some irrational number. It's 1 point, I don't know, 7, whatever it is. I don't know what it is, right? But that's what it is in exact form. And when you get your questions on that quiz, it's not going to give you some decimal answer. It's going to give you a number like root 3 over 2. So that's the answer I'm looking for. Let's try all of that now for cosine. Sorry, pi over 6. So the sine of pi over 6. Right? So now we're looking at it from up here. Right? We're changing our perspective. We're not looking at the angle down here anymore. Not down here. We're now up here at pi over 6. So remember, sine is opposite over hypotenuse. Opposite over hypotenuse. You've done this. This is grade 10 stuff now. Look at that triangle, and what would you get as the sine of pi over 6 if it's opposite over hypotenuse? Anybody? All right, look at the triangle and give me what that is, please. The sine of pi over 6. Let me bring that down some more. The sine of pi over 6 should be equal to what? Opposite over hypotenuse. What over what would that be? Anybody? Kelvin says 1 over 2. Davina says 1 over 2. Are you going to agree with these guys? 1 over 2 makes sense to everybody? Hussein says yes. Alexa says yes. Okay, good. So 1 over 2 it is. How about the cosine of pi over 6? Take you back to the diagram again. Cosine is adjacent over hypotenuse. So what should that be equal to? Adjacent over hypotenuse. What do you think that is this time? I'm not going to call anybody particular in these sessions. I will in the first session, but I'm just asking you to voluntarily jump in and tell me what you think. Alexa says root 3 over 2. Sinduja says the same thing. Brendan is agreeing. And you're absolutely right. Root 3 over 2 is correct. How about the tangent of pi over 6? What do you think that is equal to? Go back up and look again at that triangle. Tangent is opposite over adjacent. Christiania says 1 over root 3. I'm not going to agree yet. I want to see what other people think. Apparently, everybody agrees with you on that one. Excellent. 1 over root 3 is correct. So that's good. So we have a bit, and I'm going to tell you this right now. If I ever have a question where I'm asked for the sine of pi over 3, I don't memorize that it's root 3 over 2. I draw the triangle. Right? Because I'm not going to commit it to memory. I don't have the brain cells to retain all of that. So I just draw the triangle and I use my SOHCAHTOA to figure it out. All right? Okay, so that takes care of the special angles pi over 3 and pi over 6. How about pi over 4? For that, we're going to go to the second triangle. So let me see if I can squeeze that in up here. Let's find the sine of pi over 4, the cosine of pi over 4, and the tangent of pi over 4. Okay, so that's this diagram in the side over here. Okay, that was the same triangle, right? Not the right-hand one. Yeah, we're using the one on the left. No, we're going to use a different triangle because pi over 4 is not going to be in the first triangle, it's in the second triangle. Let's start off with the sine of pi over 4. So it doesn't matter whether we use this angle or this angle because they're both pi over 4, but we're looking for opposite over hypotenuse. Christiania says 1 over root 2 is what she says. I don't know. I don't know if that's right. What do other people think? Hussein, you going to agree with her? And Donna as well? You got all these people agreeing with you? That is 1 over root 2? That makes sense, everybody? 1 over root 2 makes sense? Oh, okay. I guess it does. All right. Okay. I'm not going to try to pull anything on that one. Everybody's obviously confident about that. How about cosine, though? How about the cosine of pi over 4? Look at the same triangle again. So instead of opposite over hypotenuse, it's now adjacent over hypotenuse. What is that for cosine of pi over 4? Cosine of pi over 4, what's that? It's the same. You're right. 1 over root 2 again. That one, I don't have to memorize again. I don't really draw the triangle that one because I know that for sine and cosine, they're both the same. The one that I always have to use the triangles for is the pi over 3 and pi over 6. But for pi over 4, I know it's always 1 over root 2 for sine and cosine. All right. Tan is 1, Brendan says. Really? I guess it is really 1. Okay. Let me not play around with that at all. It is 1. So guess what? We can now fill in some of the information in the chart on the next page. I don't know if any of you printed off the chart, but we can go back and we can actually fill in some of that information right now. I can answer the question for the sine of pi over 6. If you have that chart in front of you, you can go back and look at that right now. What is the sine of pi over 6? Go back and look at your chart. I'll tell you what, I'll help you out. I go back and bring the chart up for you. The sine is right there on the page. Sine of pi over 6 is equal to, what is it? It's right there, staring at you. It's 1 over 2. There you go. We'll get to cosecant later on. How about the cosine of pi over 6? Again, we worked that out already. Cosine of pi over 6 is right there in the chart. It would be the root 3 over 2. I always know that if I have the sine of any of these special angles, the other one is always the opposite. So this is 1 over 2, this is root 3 over 2. How about tangent? Let's go back and look at tangent again. The tangent of pi over 6 was 1 over root 3. So that's the answer right there. Now, let's talk about the reciprocal of each of these, right? If the sine is, of pi over 6 that is 1 over 2, what's the cosecant? It's 2. There you go, Christiania. There you go. Let's flip that number over. If the secant of, if the cosine of pi over 6 is root 3 over 2, then what's that? It's going to be 2 over root 3. And again, if the cotangent, the tangent is 1 over root 3, then the cotangent is simply root 3 over 1. which is just simply root 3. Okay, good. How about this row here, the pi over 4? Help me out here, folks. What would be the sign? We just talked about this a few minutes ago. What would be the sign of pi over 4? It's 1 over root 2. We just did that. The cosine, I think we can all remember, it was the same thing, 1 over root 2. The tangent, though, wasn't 1 over root 2. The tangent of pi over 4 was just 1. Let's take each of these and flip them over. So, the cosecant of pi over 4, root 2 over 1. And I just simply say root 2. Right? Anything over 1 is just that thing itself. Obviously, it's going to be the same answer for this. But how about the cotangent of pi over 4? It should just be 1. Okay, now, here's something we're going to be learning in the next couple of days. I think it's tomorrow we're doing the cofunctions. That the pi over 6 and the pi over 3 are kind of related, right? They're kind of related. And I can tell you this, and this is one way that you can remember it. If the sine of pi over 6 is 1 over 2, then the sine of pi over 3 is just going to be the other one, which is the root 3 over 2. Right? But you can go back and look at what we did before. Sine of pi over 3, we had that down here. Sine of pi over 3 was root 3 over 2. It's right there. So it's root 3 over 2. The cosine is always the opposite one. So I'm going to say, without even doing, I'll flip back to the next page. I'm going to say that's 1 over 2. The one I always have trouble with is figuring out what the tangent is. And I'm just going to go back to my previous page for pi over 3. Pi over 3 is root 3. So root 3. Okay, for pi over 3. Now, let's flip all of these over for the reciprocal ratio. So this would be 2 over root 3. This would be 2. And this would be 1 over root 3. All I'm doing is I'm just flipping over each one of the answers that I had for the primary ratio. So instead of root 3 over 2, it's now 2 over root 3. Instead of 1 over 2, it's now 2. Instead of root 3, it's just 1 over 3, 1 over root 3. Okay? Let me just pause there for a second and make sure everybody is on the same page with me. So we've almost filled in this whole chart, but there's some other stuff we need to talk about, which I'm going to get to in just a minute, right? If you have printed this off, then you should have been able to fill in everything that we've done so far all the way up to pi, right? And these are questions that you could have on the exercise that you're going to be working on in a little while. But there's more. But wait, there's more. Like we're selling something on the television, one of those infomercials. All right, let's see. Yes, Lynette, go ahead, please. No, because I'm doing a video, remember? You can always look at the video and see all these answers later. Okay, all right. How do you get 1 over root 3 for the cotangent again? Thank you for the question, Donna. Okay, so let me go back and look at that. So instead of root 3, remember root 3, any number, anything that you get that doesn't have a denominator, Donna, put it over 1. Okay, so since it's root 3, it's root 3 over 1. So I flip root 3 over 1, and that gives me 1 over root 3. Okay, great. All right, now let's talk about, before we get to negative rotations, which we'll talk about, what happens if I have an angle like 5 pi over? Do we need to rationalize it? No, you don't, actually, Kelvin. And so on is, yes, Donna, yes. So Kevin's question was, do we ever need to rationalize the denominators? Answer that question is no. When you get the answer on that quiz that you're going to be doing shortly, it's not going to be rationalized, okay? And Donna's question says, so when it says no, yes, put it over 1 if there's no denominator, Donna, absolutely. Okay, now, what happens when I have to get an angle that's not in the triangle, such as 5 pi over 3, such as 13 pi over 6, such as, okay, so we'll talk about negatives in a minute. Let's talk about 5 pi over 3 and 13 pi over 6. Those are not in my special triangle. So what do we do then? And we'll get to negatives in a minute. Here's what I'm going to tell you to do for that. Right? Bear in mind what we have on this page, right? So This is going to be the starting point of all of this. I'm going to get a brand new page now, and I'm going to put a circle on there. If I can find my circle tool. Circle tool, where are my shapes? Here we go, right here. Okay, so here's my circle. Just going to move that down. And I'm going to put a grid on that. Let's put a line going this way and a line going that way. And the next thing I'm going to do is, let's move the circle over a little bit here. The next thing I'm going to do is I'm going to put cast on it. Everybody remember cast? C-A-S-T? Does that sound like something? Yeah, okay. We got the memory. We remember what that is. Cast tells you what is positive in each of the quadrants. So the C starts off down here. The A is here. The S is here, and the T is here. Okay? What do those mean again? Does anybody remember what those mean again? What do those letters tell us about each of those quadrants? The C-A-S-T. You said yes, but what does it mean? Is it just spelling out stuff, or does it cosine, yeah, all, sine, and tan? Absolutely. But what's happening when, for instance, you are in quadrant, let's say quadrant 2. Let's put a number on the quadrants, by the way. This is 1. This is 2. This is 3. And this is 4. I'm using Roman numerals here. What is it telling you about each of those? If I'm in the quadrant, that's an S quadrant, which is sine. It means everything is negative except sine. That's right. Thank you. Thank you very much for saying. So it tells you what's positive in that quadrant. They're all positive here. Sine is positive here. Tan is positive here. And cosine is positive here. Now, let me tell you why this makes sense based on what I told you earlier on. I said that think of sine as being my y coordinate. Think of cosine as being my x coordinate. And think of tan as being your y divided by my x. Well, look at the first quadrant. I'm on the positive side of the x-axis. I'm on the positive side of the y-axis. So it means that my sine will be positive because sine is my y coordinate. Remember, sine is my y. My cosine will also be positive because I'm on the positive side of the x-axis. And tangent is my y divided by my x. That's going to be positive as well. So they're all positive. Let's come over here. I'm on the negative side of the x-axis. That means that cosine is going to be negative because cosine is my x. I'm still on the positive side of my y-axis. So that means that my sine is going to be positive. But if I divide the negative by the positive, I'm going to end up with a negative. So tan is also negative. Down here, I'm on the negative side of the x-axis, the negative side of the y-axis. So both cosine and sine are both negative, but because I'm dividing two negatives, I get a positive for tan. That's why tan is positive here, but the other two are negative. In this quadrant, I'm on the positive side of the x-axis, so cosine is positive because cosine is my x-coordinate. I'm on the negative side of the y-axis, so my sine is negative. When I divide my y by my x for my tan, I get a negative because one is positive, one is negative. That's why it makes sense. That's why this casting makes perfect sense with what I said to you earlier on about sine being my y, cosine being my x, and tangent being my y over my x. It kind of makes sense. It all fits in. Okay, good. Now, let's take an angle that's not in the triangle. So this is what we're working with here, right? Cosine is positive here. They're all positive here. Sine is positive. Tan is positive in those quadrants. Now, let me take you back to the special triangles. The special triangles only consider what are called acute angles. So pi over 6 an acute angle is less than 90, or less than, I shouldn't say 90. I'm going back and using degrees again. It's less than pi over 2. Pi over 3 is less than pi over 2. Pi over 3 is less than. All of these are less than pi over 2. These are all acute angles. Acute angles mean they're less than pi over 2. But what happens if we get to an angle, such as in the table, 5 pi over 3. What am I supposed to do with that? Right? How am I supposed to give a special angle for that? Well, we're going to find out right now. 5 pi over 3, we need to figure out where that angle is. That's the big challenging thing about it. Which quadrant is that angle in? Let me remind you about something. I'm going to label the angles that we're starting off with. This we said was 0. We said this was pi over 2. We said this was pi. We said this was 3 pi over 2. And of course, this is the same thing as 2 pi. 0 or 2 pi. All right. Where is 5 pi over 3? What quadrant is that? How far are we going to have to go? What quadrant are we going to end up in to get to 5 pi over 3? That's the big question. Sindhu just says the fourth quadrant. Is that right? Is it really the fourth quadrant for 5 pi over 3? Think about that. I'm not saying you're right or you're wrong. I'm just asking a question. Quinn says, everybody's agreeing with you. That's good, because you're right. If you think about it, 5 pi over 3 almost takes you back to 2 pi. Almost. You're not quite there yet. It's approximately somewhere, let me put that as a line here. It's going to be somewhere around maybe here in the fourth quadrant. And the question is, what? And the quit is something else. And the question is, what's called related acute angle, sometimes referred to as the RAA. RAA, and I'll write that out, related acute angle. What angle can we use to represent 5 pi over 3, which is an acute angle? Well, remember that what we're always going to look for is an acute angle. So do we go the acute angle from the x-axis or from the y-axis? Well, it's always from the x-axis. So what I'm really trying to figure out here is how far am I from the x-axis if I'm measuring from here all the way around to here, and this is 5 pi over 3. So you're all right. It took me to get to the fourth quadrant for this to work. Right? That's where my 5 pi. But how far am I from the x-axis? Right? What is the distance? What is that? What's called related acute angle, measured from the x-axis. How far do I need to go to get to the x-axis? That's the key to this related acute angle, this RAA. How far do I need to go to get to the x-axis? Can anybody help me out with that? Right? What's that little red line there? That little red angle. How far is that? Right? If I'm at 5 over 3, 5 pi over 3, and I'm trying to get to the x-axis, right? What's that distance that I need to go to get to the x-axis? Right? I'll give you a clue. It'll be whatever 2 pi is. So the black line is the 5 pi. Yeah, well, it's a green line actually. I guess it's not the best looking green line. Maybe I should erase that and put it back in. It's actually a green line. All right, let me put that back in again. So this green line is my 5. This is my 5 pi over 3. So we are using, I guess you could call it the coterminal angle, Kelvin. Yeah. So the black line, or the Seduja, the green line, okay, is my 5 pi over 3, measured starting from what's called standard position, starting from the positive side of the x-axis and going all the way around to here is 5 pi over 3. But the question is, what's the related acute angle? What angle would take me back to the x-axis, the closest x-axis? What is that gap? And the way we would do that, quite simply, is to take the 2 pi and minus that 5 pi over 3, and that would give us what? Can anybody help me out with that? What's the related acute angle for 5 pi over 3? So we're trying to get, this is 5 pi over 3, by the way. Trying to get the RAA for that. What's the RAA for that? Right? What is that gap? How far do I need to go from where I stopped? I stopped right here, where I circled it. How far do I need to go to get back to the x-axis? What's that space? What is this red line here? How far is that? What angle is that red line? In radians. In radians. I'm sorry to have to do that to you, but it's in radians. What is the RAA there? Can anybody help me out with that? I'll give you a bit of a sort of a rule of thumb about that, but I want to see if anybody can figure out what that angle is first of all. What is that angle that's going to get me back to the x-axis? Nobody? It's pi over 3. And one way for me to get that is to take the 2 pi, which is what a full rotation is, and subtract the 5 pi over 3 from that. Now, think of this 2 pi over 3 as being an improper fraction. Same thing as 6 pi over 3. That's the same thing as 2 pi, right? 6 over 3 is 2. And you're minusing from that 5 pi over 3. So that would give you, the denominators are the same. So I give you pi over 3. Okay? Does that make sense? I want to make sure everybody's okay with that before I go any further. Right? So all I'm doing is I'm just trying to figure out what that little gap is that takes me back to the x-axis. And it's the same thing as taking 2 pi, because I haven't quite, see, I didn't quite finish the rotation. I had a bit more to go on. I'm trying to figure out what's that gap there, right? What's that, what I call deviation? How far am I from the x-axis? I'm pi over 3 away. Now, the clue to this is just simply use whatever the denominator is to figure out what that gap is. That always works. Okay, so if this was 5 pi over 3, just use pi over 3 as the RAA. Okay? So, let's try to answer the question. I'm going to erase all of this. Yeah, I'm sorry about that squeaking here. I really have to do something about the squeaking here. Let me erase all of this. And let's just answer the question about, okay, let me see who this is. Quinn, yes, Quinn, go ahead, please. Pi over 3. Okay. So Quinn's question was, how do I get the pi over 3 by subtracting 5 pi over 3 from 2 pi? Change 2 pi into 6 over 3. 6 pi over 3, that is. Right? Would you agree that 6 pi over 3 is the same thing as 2 pi? Let me start with that, Quinn. 6 over 3, of course, gives us 2, right? And what I'm doing here is just getting a common denominator of 3. So, if I have a common denominator of 3, they're both over 3, then it means that if I'm subtracting, I've already found the common denominator to be 3. I'm just subtracting 5 pi from 6 pi, which is just 1 pi. Okay, because they both have the same denominator. All right. Okay. Yes, Donna, go ahead, please. In the fourth quadrant? I'm glad you asked. So your question was, how do we know that 5 pi? I'm repeating your question so that it will be on the video. How do we know that 5 pi over 3 is in the fourth quadrant? That's the part that's the most challenging, and I agree with you that it's good to ask that question. So let's do it this way. Let's do it this way. Think about each quadrant and where it stops, right? This stops at a half of pi, the first, and where I'm pointing to right now. You can see when I point with my little stylus, right? So the pi over 2 is half of, so okay, let's do it this way. We start at 0 here. The first quadrant only goes up to a half. The second quadrant only goes up to a full pi. The third quadrant goes up to 1.5 pi. And the fourth quadrant takes you up to 2 pi. So far, so good, Donna? Does that make sense? Okay, good. So think about where 5 over 3 is. Turn it into a decimal if you like. 5 over 3 is the same thing as 1.6. You can put it on a calculator if you like. 5 over 3, not 1.6. Yeah, it is 1.6. Put it on a calculator if you like. Right? Have you done that? Are you getting the same thing? Right. I'm getting 1.6 if I did that. 1.7 or 1.7. 1.7. So think about this. This is 0. This is a half. This is 1. This is 1.5 or 1.5. This is 2. What you have is 1.6, 1.7 if you round it correctly. So where would you put 1.7 if this, the first quadrant goes up to a half, this goes up to 1, this goes up to 1.5. Isn't 1.7 somewhere between 1.5 and 2? Would you agree with that? So you can do it that way, right? turn it into a decimal. And if it's in a decimal, ask yourself, where does that fit into the four quadrants? If I start at 0, 0.5, 1, 1.5, let me point to it as I go along. 0 is here, half is here, 1 is here, 1.5 is here, and 2 is here. So once you get into a decimal, figure out where that takes you. Okay? Yeah, you're welcome. Good. All right. So let me go back to this now. So we're dealing with pi over 3, and we've already agreed that's in the fourth quadrant. All right, Donna was getting some clarification on that, and I think a lot of you were convinced before that it was the fourth quadrant. So now we know it's the fourth quadrant. And then we also got this related acute angle. Quinn was asking about that earlier on, and we said the related acute angle is pi over 3. All right, and why is it pi over 3? Is whatever it is that you need to get to the x-axis. And a little sort of rule of thumb, little hint is that just look at the denominator of whatever the special angle is. That will tell you how far you are from the x-axis. If it was 5 pi over 6, then it would be just pi over 6 away. That's kind of my little rule of thumb that can help you to figure it out. So what we're going to do is we're going to look at the, so let me go back to the chart here. The chart was, well, we're going to find cosine, sine, and tangent. We're going to get them all. Cosine, sine, and tangent for 5 pi over 3. So let's start off with the, let's do it over here, actually. So sine of 5 pi over 3 is exactly the same thing as the sine of pi over 3, whatever the related acute angle is. But because you're in the fourth quadrant, where only cosine is positive, it's going to be the negative of sine of pi over 3. So go back and look at the sine of pi over 3, put a negative in front of it. Right? What was the sine of pi over 3 again? Can anybody remember that? Go back and look at your notes and tell me if you can find the sine of pi over 3. Anybody? What's the sine of pi over 3? You can look at your charts for that. It's okay. The sine of pi over 3 was what again? Nobody remember? Should I go back to my chart then? Sine of pi over 3. It's right here. It looks to me like it's root 3 over 2. Perfect. So my answer for this question is root 3 over 2, but negative. Right? Why is it negative? I'm in the fourth quadrant. Now let's answer the question as to the cosine of 5 pi over 3. What is that equal to? Well, it's the same thing as the cosine of the related acute angle of pi over 3. Do I make this negative as well? Should I make this negative or should I keep it? No, I should not because it's in the fourth quadrant. So it's still going to be, as Chrisania just said, 1/2. Right? It should still be 1/2 because the cosine of pi over 3 is 1/2. How about the tangent? We'll fill this in the chart in a second of 5 pi over 3. Well, that's equal to the tangent of pi over 3. But should I make this negative? It's in the fourth quadrant, so it should be negative. And therefore, it's whatever the negative of pi over 3 is, which I forget, so I have to look back at my chart. The tan of pi over 3 is root 3. So it would be the negative of root 3, which I think somebody said already. Negative 1 over root 3? Why is it 1 over root 3 for... Yeah, I'm trying to figure out why you said 1 over root 3, Chrisania. Because so tan of pi, unless I got that wrong, I could have got that wrong. That's possible. The tan of pi over 3 is just root 3. So it shouldn't be 1 over. Does that make sense, Chrisania? I just want to make sure that we're on the same page here. Okay, good. So it's just minus root 3. So minus root 3. And here's your answer. So we can now go ahead and fill in that chart for 5 pi over 3. 5 pi over 3. So we agreed that this was going to be minus root 3 over 2. This is going to be, this is cosine here, positive 1/2 and negative root 3, right? Based on what we just did for those angles. So the sine is negative, the cosine is positive, the tan is negative. But the reciprocals would be the reciprocals that you expect. So this would be minus 2 over root 3. I kept the minus on the top. This would be positive 2, and this would be minus 1 over root 3 for the reciprocal angles. For the reciprocal angles. Okay? Okay. Now, let's try. I'm not sure if I want to give you 13 pi over 6. I'm going to cross that out and put it, because I don't think on the exercise I gave you an angle that was over 2 pi. I'm going to call this 11 pi over 6. No, I don't want to make 11 pi over 6. Let's make this 5 pi over 6. Or, okay, 7 pi over 6. Let's do 7 pi over 6. So I'm just checking it on the fly here. 7 pi over 6. Let's try this out now. Let me draw another triangle. Sorry, another circle. Let's see if hopefully I can finish this. I'll put my lines in again. I'll put my cast on there as well. C-A-S-T. And the question I'm being asked now is, where is 7 pi over 6? What quadrant is 7 pi over 6 in? Can anybody help me with that? Quinn says quadrant 3. Again, what you could do, I'm not going to agree with Quinn yet. What you could do is turn that into a decimal, the 7 over 6 that is, and compare it to, remember, this is 0. This is 0.5 pi. I'll put it in decimals to make it easier for you. This is just pi. This is 1.5 pi, and this is 2 pi. So where would that be? So Donna seems to be agreeing with Quinn, but everybody else, where are you on this? Where is 5 pi over, what did I just say? What are we doing again? 7 pi over 6, sorry, 7 pi. We're trying to figure out where 7 pi over 6 is. Okay, so everybody's agreeing, and that's a good thing. That's a good thing. So here's our line for 7 pi over 6. 7 over 6 is approximately 1.2, I think. So that's definitely somewhere between 1 and 1.5. So based on what I just told you, so remember, we're doing 7 pi over 6 now. 7 pi over 6. So based on what I just told you, what do you think this related acute angle is right here? What's the RAA that we're looking for on this? I gave you a little hint as to how you could find that RAA for 7 pi over 6. What do you think that is, folks? 7 pi over 6, the RAA. We need the RAA. So the sine of 7 pi over 6 is equal to the sine of what related acute angle? Anybody? Remember, it's just a denominator. We just gave that hint a few minutes ago. Look at that denominator, right? So it's a sine of what? What do you think, folks? It's pi over 6. There you go. But should I make it negative based on the fact that it's in the third quadrant? Is it going to be positive or is it going to be negative? It's going to be no. I don't know what no is. I said positive or negative. I don't know if no is going to answer the question. It is going to be positive for sine, you think? Chrisania says positive. Donna says negative. So you're both not agreeing with each other on sine. Right? Hussein says negative. Brendan says negative. But what are the, okay, so Chrisania is now changing to negative and is in fact negative. So the sine of 7 pi over 6 is equal to the sine, the negative sine of pi over 6. And if I believe, I think it is minus a half, but you can double check that for me, please. Right? I literally don't memorize it. So I think it's minus a half, but you can double check that. And then we can answer the question about cosine of 7 pi over 6 being the same thing as the cosine of pi over 6. Should that be negative as well? Maybe my circle Ross, okay. Should that be negative as well? What do you think, folks? For cosine in the third quadrant, it should be negative, yes. And I believe this should be the minus root 3 over 2, but you can double check that. And finally, how about the tangent of 7 pi over 6? what is that equal to? Well, remember, it's equal to the tangent of pi over 6. Use your related acute angle. And should I make that negative, remember it's in the third quadrant, it's positive. So whatever the tan of pi over 6 is my answer. Let me go back and find that because I don't know what it is. The tan of pi over 6 is 1 over root 3. So let me put that in. Yes, go ahead, please, Quinn. Yeah. Yeah, absolutely. If I can find it. Yeah, here we go. No, that's not it. It is. Yeah, there we go. Mm-hmm. I am. Yeah, I am. Yeah, yeah, I am. And in fact, it would be adding. It would actually in this case. Let me just think about that for a second. Now, you're going to be what you're doing is adding pi over 6 onto pi. But let me just put it this way. The shortcut for this, and by the way, your question was, how am I getting the pi over 6? The shortcut is, and I think I'm going to urge you to use a shortcut at this point, is to just simply look at the denominator, because that denominator is always the clue. So the denominator in this case is 6, so it's going to be pi over 6. If the denominator had been 3, it would have been pi over 3. So let's just use that going forward as a shortcut to figuring out what's the related acute angle. Does that answer the question, Quinn? Okay, perfect. And we're just going to do tan, and people are agreeing that tan should be positive, so the tan of pi over 6 is, should be the answer. And I just looked, I think it was 1 over root 3. So there's your answer. Now, the only one thing I have left to do with you is what happens when we're going in a negative direction? What does that mean? Okay, oh, so we look at the pi and the denominator. Yes, Donna. Right, so it's always going to be pi over something. If it was pi over 4, if there's and so an answer like, for instance, let's say 7 pi over 4, the related acute angle is pi over 4. Okay, and so on and so forth. Okay, now let's do one more thing, which is going in a negative direction. I'm not going to fill in the chart for 7 pi over 6. I want to go for one of those that's going in a negative direction. So let's tackle minus pi over 2. And let's tackle minus pi over 3. When I'm done those, I'm going to stop. Okay, let's tackle those two and see if we can figure out what's going on here. Minus pi over 2. Okay, where is that taking us? Where do we go with minus pi over 2? Well, the first thing I want to say to you is this. We're no longer, I'm going to erase all of this ink here. We're no longer, let me take away also this line. We're no longer rotating in a counterclockwise direction. Now we're rotating in a clockwise direction because clockwise is negative, sorry. So instead of me going like this, instead of me going in that direction, I'm going to be going in this direction, starting off at 0. So this is still 0. Let me label it. This is still 0. This is still considered to be half a pi or pi over 2. Let's put half a pi there, make it easier. This is still considered to be pi. This is still considered to be 1.5 pi. That's really all it is. But what about if I'm doing minus a half of a pi? Where am I going then? I'm starting at 0, and I'm not going this way. I'm going this way. Where am I going to end up for minus half a pi? Q1, Brendan says. Anybody agrees with Brendan on that? I'm going to be in Q1. So if I'm going the opposite direction, I'm going in a clockwise direction. Quinn agrees with Brendan. Dawn agrees with Brendan. So you're saying I'm going to end up somewhere up here in the quadrant 1. Edmund. All right, I'm going to have to disagree with you this time. Sorry. I'm rotating in this direction. And I'm rotating a half pi in this direction. Here's where I'm going to end up. I'm going to end up right here on the negative side of the y-axis. That's where I'm going to end up. This rotation I've just done is a half pi, which is what you could call, if it was a positive half, it would have been going this way. But it's a negative half, so I'm going to be going this way. Okay? And therefore, guess what? I'm going to end up right on the x-axis. Sorry, on the y-axis, but on the negative side of the y-axis. So really what I need to be looking at is these coordinates that we did the first time. And the coordinate here is going to be 0, -1. This is when we were looking at the circle originally. So when I ask about sine, cosine, and tangent, think about x-coordinate, y-coordinate, and y over x for sine, cosine, and tangent. So let's answer the question now. So for the sine of minus pi over 2, remember, I'm going to remind you, sine is my y. Sine is my y. So what's the sine of minus pi over 2? Anybody? What's the sine of minus pi over 2? Look at the coordinates. Focus on the y's, the y coordinate. Can anybody tell me what the sine of minus pi over 2 is? Hussein says -1. What do other people think? Alexa says -1. What do other people think? And Donna agrees. It is in fact -1. It's -1 because of where I am. Not because it says sine of minus pi over 2. It's because of where I am. I ended up going clockwise, ended up on the negative side of the y-axis, and therefore my coordinates are 0, -1. It says sine, so I'm looking at my y, and my y coordinate is -1. Okay, cosine of minus pi over 2. Can anybody give me the cosine of minus pi over 2? What is that equal to? The cosine. Do you not find the RA? No, you don't, because you're sitting. That's a good question, Hussein. Hussein is asking, do I not find the RAA in this case? No, not when I'm sitting on the x-axis or the y-axis. There is no RAA there, right? The only time I have an RAA is when I'm not sitting on the x or y-axis, but I am sitting on the x or y-axis. In this case, I'm sitting on the y-axis. There is no RAA. The RAA is always measured from the x-axis. But if I'm sitting on an axis, then I don't use RAA. I just use the coordinates. Okay, what about the cosine of minus pi over 2? Let's answer that question. We have about 7 minutes left. What is the cosine of minus pi over 2? 0 is correct because it's my x-coordinate. What about my tangent of minus pi over 2? Can anybody help me with that? So wait, was the rotation counterclockwise is based on, okay, well, let me go back to Brendan here. Brendan, another question. So the rotation counterclockwise is based on the fraction, correct? By the way, remember I'm going clockwise now, Brendan. So right now we're doing a clockwise rotation for negative is based on the fraction, correct? I'm not sure I understand the question. The fraction is based on the fraction, correct? Well, we're using minus pi over 2. When if it's over 2, or if it's like a whole number like pi, then it's always going to be sitting on an x or y axis. So let's just make sure we're clear on that. Okay, all right, good. So I'm asking about minus pi over 2 now again. It's y over x for tan. So yes, it's undefined. That's the answer to that question. All right, okay. So I know we're coming up to the end, but so we can fill that in for minus pi over 2. Let's try one more and then I'm going to stop. All right, one more and then I'm going to stop. Oh, wrong way. How about if I had minus pi over 3? Minus pi over 3. Where am I going to be for minus pi over 3? Let me erase all of this stuff here and see if anybody can tell me where they think I'm going to be for minus pi over 3. Again, I'm going clockwise this time. What quadrant am I going to be if I'm going I'm starting at 0 and I'm going this way. Where am I going to end up for minus pi over 3? Quinn says quadrant 3. Kelvin says quadrant 4. You can't both be right. So one of you may be right. In fact, you both could be wrong, by the way. I'm not saying either one is right or wrong. What do other people think? Brendan says 4. What do other people think? Anybody else? Anybody else? Chrisania says 4, and it is in fact quadrant 4. I haven't yet even hit this line yet because this line is, let me label it if I was going in a counterclockwise direction. This would be 0. This would be this would be minus 0.5 pi. This would be minus pi, same thing as positive pi. and this would be minus 1.5 pi if I'm going in a clockwise direction. So because, let's see, Donna, yes, go ahead, Donna. The negative side of the y-axis, yeah? Let's think about it this way, right? If I was going in a counterclockwise direction, they start off at 0 again, then half a pi takes me up to the positive side of the y-axis, correct? Would you agree with that, Donna? Okay, so if I'm going in a negative direction, which means clockwise, wouldn't that mean that a half would take me down to the negative side of the x-axis, of the y-axis in that case? Because I'm going a half but in the other direction. So 1/2 positive takes me to the positive side of the y-axis. A half negative takes me to the negative side of the y-axis. Does that make sense? But it wasn't in quadrant 4. It's on the line. So don't say quadrant 4, because when you're on the line, you're in between two quadrants, which means that it's not in either quadrant 4 or quadrant 3. It's on the line. Okay? It's actually on the line. Okay. So let me just finish this up very quickly. What was I trying to do again? I was trying to do, I forget what I was trying to do. Which angle did I say I was going to do with you again? I think it was minus negative pi over 3. Okay. And we agreed eventually that negative pi over 3 is going to take us somewhere down here. Let me draw that in manually very quickly. So that's really somewhere down here. That's minus pi over 3. And the related acute angle, very, very quickly, would be what? What's the related acute angle for minus pi over 3, you think? How far am I from the closest x-axis? What's that gap? Or just use that little shortcut that I gave you a few minutes ago. Minus pi over 3, what's the related acute angle for minus pi over 3? What do you think? Anybody? Doesn't matter. Okay, I'll just tell you because we're running out of time. It would be pi over 3. It is pi over 3. Yes, Quinn, it's actually pi over 3. So I'm going to answer the question for sine, cosine, and tangent very quickly. The sine of minus pi over 3 is the same thing as the sine of pi over 3. But should it be negative or positive? Well, we agreed it's in the fourth quadrant, so that should be negative. The cosine of pi over 3 should be equal to the cosine of pi over 3, and it should be positive. Why? Because I'm in the fourth quadrant. The tangent of pi over 3 should be the same thing as the tangent of pi over 3, but should be negative because of the quadrant I'm in, the fourth quadrant. And let's just finish that up very quickly. Sine of pi over 3 is, I think that's root 3 over 2. You can double check that on for me, please. That should be negative. I believe this is a half. And I believe this is, I'm going to say it's root 3, so I'm going to say minus root 3. Those need to be checked because I'm kind of rushing here to get this done in the time that we have left. All right, so if you go to the That Quiz link, which is in, when is homework due? And the questions you're seeing right now are the possible questions on the quiz homework check, right? Yes. So you should see in the That Quiz page, once you've logged in, you log in with your student number, you see questions similar to the ones that we've just done. If you're getting more than 2 wrong in a row, stop. Come and see me in that 3 to 4 period that we have today, and let's go over it in scroll up first, and I can, yes, and let's go over it in some detail there. Okay, yes, Quinn, go ahead, please. What is the password again? It's your student ID. Go ahead, Quinn. 3 to 3:30. Yes, yes, yes. Yeah, it is. Yeah. So it's going to be multiple choice. They're going to give you like an angle like this, and then you have to choose from, I think, like 6 options. Oh no, exactly, exactly. So your question was, just to repeat it, is you're not going to have the visuals. You can use the chart that we just did, and that should help you out. And again, stop if you're getting too many of them wrong. Just come see me and we can slowly go through it later on today between 3 and 3:30. And password, like I said, is in fact your student ID number without the S. Don't put the S in. All right. Yes, Donna, please go ahead. It's just a homework. It's a homework that is under that quiz page. If you go to the calendar and click on the link that's there, it will take you to the that quiz page. You just log in with your student number, pick your name, put your student number in, and just do that quiz. And that's for your homework later on. Okay? You're welcome. Okay, folks, I'm going to stop recording and I'm going to tell you goodbye until tomorrow. You take care now.